Yeah. And I keep giving like online talks anyways. So.
I know. I have been following you. In fact, somebody told me you were taking some session in, I guess, Philippines universities. I think you had taken some session.
That wasn't me. Probably somebody from Parity though.
Oh, no, somebody told me Radha. So it must be you, I guess. Uh,
I don't,
uh,
not from Philippines though.
Not
Like
from some Asian country. It was Philippine or I mean, you gave an address in which country, in Asian country? I think it was last year, not this year, I guess.
I think last year I did like, I didn't go in person, but I did like a virtual session with some people in like Vietnam or
Vietnam, correct,
yeah,
correct. Yeah, Vietnam. Yeah. So he was telling me Radha, and I was not able to understand. Then I figured out to Polkadot, he was saying Radha. So then I
Oh, okay.
figured it out. It must be
Yeah,
you.
yeah, 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 that's true.
Yeah. Excellent. Yeah, I missed meeting you this time when you were in Bangalore.
Yeah, I mean, we had like really good response in India. I think
Yeah.
the idea is to scale up initiatives in India more.
Yeah, no, I agree. I think mm, that will be a big help because I think it is little complex for people to appreciate in the beginning, but with assistance, I think this journey becomes much easier.
Yeah, yeah. I think the main focus, at least this few months, is to put together the resources that for absolute beginners, like if they want to get into like Polkadot, like what do we do? So
Mm.
I'm personally like attending the Polkadot
Maybe.
Blockchain Academy in
Yeah,
UC
yeah.
Berkeley.
That's in California,
Yeah,
somewhere,
it's
right?
in UC Berkeley in
Berkeley.
July.
Mm.
So the idea is that while taking that, I will try to focus on creating educational content that is more accessible. I mean, there you have experts coming and talking for like 2 hours at a stretch in a meeting, but again, they're not very focused on educational aspect. So they're going to share their expertise. How do you digest all of that and then create some accessible like content out of it?
Mm.
So my focus will be that, like, listening to all those experts, highlighting the takeaway points and then sort of putting it in an accessible way, creating videos so that people can learn at their own pace rather than they having to attend like a blockchain academy somewhere.
Yeah, no, I agree. I think, and you really need to maybe abstract the complexity and make it consumable more at a mass level, I guess.
Yeah, especially the university, like university level courses. So right now we don't have curriculum designed for like university level course, right? So if somebody wants to learn about blockchain, Web3, and Polkadot, that should be packaged together into a course. And then we teach them the concepts of Web3 and then show them how they can implement using one of the blockchains. So for us, the focus is Polkadot. So the courses will have the theoretical component and like the application component as well.
I agree. Wonderful. So guys, while we start in a few minutes, I just want to have everybody understand we have got Radha from Web3 Foundation, and Radha is one of the most sought after speakers, when it comes to Web3 and Polkadot. And we are thankful to Radha for giving his time today and speaking with all of you. And Radha, this batch that you are talking to, this is our continuous education program batch, and
Mm.
people have been trained on fundamentals of Rust. And before that, we also have trained them on the blockchain ecosystem as such. I mean, such as what's the interpretation or validation, how do blocks get formed, and etc. etc. All those things that we need to know. And then we also have trained them on the premise of becoming a Web3 developer, such as, how do you really interact with the blockchain, what are the roles of the JS libraries, for example, all other foundational things, such as where do oracles come into picture, how do you manage the storage in a decentralized way, etc. etc. So we have given them foundation,
Yeah.
And we expect that, based on this, I understand this is going to be a steep journey for them, but then I expect them to be working on some projects. Now, these projects may not be really very complex projects to begin with, but then maybe some foundational MVPs where they can learn these things and then gradually grow on to be delivering something more complex in some time in future.
Yeah, sounds good to me. So how long have the participants spent in the continuous education program?
So this has been after the Chennai we started. So I'll say we ended Chennai CEP on 31st. So we started on 7th. So we are looking at a month or even little more than that, a month already.
Okay,
Maybe
very
somewhere
cool.
in that
I
range.
mean,
Yeah.
that gives me like more freedom to talk about in-depth stuff during today's session. So what I planned was I'm taking 2 sessions, right? So today
Yeah.
I'll give the introduction to Polkadot, and then Friday is when I'll go deeper into like the development aspect on it.
Right.
So I know like they've already been shared with like this CryptoKitties like tutorial,
Yep.
which gives a good walkthrough of all the fundamental concepts that you need to be familiar with in Rust to be able to write code in Substrate. So you still have time, like till Friday, to grasp all of that, to to digest the session that I'm giving on Friday. But today we'll keep it like high level with some mostly the things that you mentioned, right? So
Right.
how do you interact with the blockchain? In this case, it's Polkadot.
Right.
What kind of tools exist in the ecosystem, and so on and so forth. So let's get started. Can I share my screen?
Yeah, so I'll just Deepak Singh. There is one the formality that Deepak does before the start of the program. He'll share the leaderboard of the quiz. So what really happens when we teach something, we have a quiz at the end of the session, and people take the quiz, and we share the result of that quiz maybe for 30 seconds, and then we can get started. Uh, just one more thing, FYI, Radha, that many of these folks have also attended our Alt Hack program on ground in Chennai. So they definitely have much more perspective than just spending this time. So because that was 8 days immersive program, right? So we really have covered several things in that, such as fundamentals of NFTs, metaverses, oracles. I have personally taken sessions on blockchain foundation. So we really have maybe have them go through several of those concepts also.
Very good. Then in that case, like I'll shorten my presentation today. I already see in the
But I
chat.
think anything coming from you is valuable to these guys. So
No, what I mean to say is I'll make it more interactive.
yes.
So I already see some questions popping up in the chat.
Okay.
So what I'll do is so this is like a general presentation, right? So with the expertise that people already have here, I can do it at a faster pace, and then we can open up the field for questions. I'll try to answer them, and then based on that, I'll modify my presentation on Friday to encompass like the topics that they're really interested in.
Fantastic. So I think Deepak, before you go and show the leaderboard, I'll take 30 seconds to formally introduce Mr. Radha. So
Absolutely.
good evening, everybody, and good afternoon, Radha. Radha Krishnan, first of all, thank you, Radha, for taking time and talking to our student developers. Folks, just to introduce Radha, Radha Krishna is a technical education lead at Web3 Foundation, which nurtures technologies and applications in the fields of decentralized web software protocols. Prior to joining Web3 Foundation, Radha was a faculty at the Department of Computer Science at University of Vermont, and he has an MS and PhD degree in computer science from the University of Buffalo, the State University of New York. Radha is, he is very excited person to put his skills to use for educating professionals and the general public alike about the vision of Web3 and its technology stack. And when I think of Web3, when I think of Polkadot, when I think of Substrate, the first name that comes to me is Mr. Radha, and Radha has been doing a great service to this Web3 community, and the the overall software community at large. So with that introduction, I'll hand it over to Deepak Singh for 30 seconds to show the leaderboard, and rather then we can start with the session for the day.
Sure.
Yeah, Deepak.
Yes, absolutely. So first of all, it's great to have you again, Radha. I mean, it's always fun to see you at the IBC portal. And obviously, one of the things that is always, I mean, I always wonder when I see your name and whenever you come for a session is the commonality between Radhakrishnan, Dr. Radhakrishnan and Radhakrishna is that you guys are both revolving around education.
Yeah.
Yeah. When I was in school, I even like dressed up like him, like for like a school event. So
Wow.
Oh, amazing, amazing. So I always kind of have a hymn in my head. Okay, fine. These both guys are having a similar journey revolving around students and education. So that's quite fun to see. And obviously we love how you teach. So it's great to have you once again on the platform. So basically, this is basically the leaderboard of our previous session, which was the fifth session 5 of Rust. And guys, first of all, I want to congratulate everyone who made it to the leaderboard this time. It's always great to see some new names. Praveen sir, if you see, there are many names which have been repetitive for the entire 5 sessions. And it's wonderful to see you all. I will start taking the names first. We have Karthikeyan V, Kirtana R, Anuvan Sherin, A. Shubhaselvi, Ritika S, Sanjay, Harish, Dinesh, Kirutika, Surinder, Pommi Sujita, and Mugil Vendan. Guys, congratulations. 18 was the number that we had to lock in. We couldn't go at 17 or 16 because we had so many people scoring such wonderful marks. So we had to just lock in the number at 18. So once again, congratulations and keep up the amazing work. We have today Mr. Radha over here and just try to take the maximum from him, try to ask as many questions to him, and obviously once the session ends, try to connect with him on LinkedIn or his social media platforms. He's readily available to answer your questions and your doubts anytime. With that, Radha, welcome once again, and the session is over to you. Please.
Thank you. So let me start with screen. Okay, can you see my screen?
Yes.
Perfect. Let me move this a little bit. Okay. Yeah, so what we'll do today is, just get the sense of like what Polkadot is, how the ecosystem generally works, what are the tools available on the blockchain, on Polkadot, for you to like build your own blockchains, right? So let's get started. Yeah, so I'd like to, originally I used to like jump into like what Polkadot is, but I think for a streamlined, group like you who are passionate enough to attend like a continuous education program, I felt it's appropriate to tell you the actual vision, right? So why are we all doing this? What is Web3? What is Polkadot doing for Web3? It all starts with this one entity, right? So blockchain. So what is a blockchain? So you have all these blocks with data which are linked together cryptographically. The beauty of this data structure is that if you try to modify any sort of data in any of these blocks, the chain will break. So the link will no longer exist because if you change the data, it's going to change the hash, and the blockchain data structure wouldn't agree for that. And why do you need such data structure? You need it to set things in stone. Now, so right, Web3 has like jobs, Polkadot has jobs and stuff like that, but that's one thing. But the whole reason Web3 exists is because there is no place where we can look for truth right now, right? So there's so much of fakeness everywhere in terms of like AI generating like, fake data, the mainstream institutions like lying to us about like, stuff they shouldn't be lying to us. So we need, or in general, like people found the need to have a place where you could actually look for truth. When somebody says like, I purchased this land, in Andhra or somewhere in India, that has to be the truth. Like you purchased it, and then there has been a legal contract that has been executed. and that has to stay that way. It has to be registered somewhere, and nobody should be able to like create like a fake documentation or whatsoever. So blockchain data structure is going to help with use cases like that. And with those use cases in mind, I want you to focus on building applications. So blockchain is not for every use case out there. For instance, when people say, can I do streaming applications on blockchain? No, because blockchain is like very redundant. There are thousands of nodes that are running the same software, thousands of nodes that are downloading this entire chain, adding new blocks to the chain. So think about that. This blockchain systems are very redundant, and then they're very helpful for anything that needs to be set in stone. So how does all of this work? Is like, first of all, like Web3, we're talking about giving users control over their data, right? So you are right now, like Facebook, Google, they make billions of dollars purely out of like the content generated by someone else. So what is Google doing? Their main source of revenue is like creating search engines. And what does search engine do? They go to internet, they crawl on all the web pages, index them, and then sort of, it's all the content that is not generated by them, by someone else. And, that's their business model. Instagram, Facebook, TikTok, all of them, like they're not generating any content. The users are generating content and they are getting the revenue out of it. So fundamentally, the Web2, the current internet world, it's being like monopolized by these entities who are not the creators, but who are just like creating platform for delivery of the content. So Web3 is like a new model for internet where you as a creator, you as a contributor get your fair share from the whole pie of cake. Like, you get your piece. And the only way the Web3 vision will work is through code, which you're going to learn through this program. You're going to learn how to write code for building Web3 applications. It's important that that code is sort of like flawless, bug-free, has no vulnerabilities. Anybody can audit the code and see, okay, this is what exactly it does, and then it succeeds. So one clear example for this is Bitcoin. So Bitcoin software, like it has been written. I mean, there have been improvements, but at the end of the day, it has never been like hacked, right? So the only reason it couldn't be hacked is because everything was transparent from the beginning. It has been open source. People know exactly how the code works. Mathematics will never fail you. This is how things work. And yeah, so the same thing applies to the Web3 applications that you're building to. You build the code, you show it to everybody, you say that this is how this is going to work, and there you go. People start using it. The code just runs on different nodes on the blockchain network, and everybody gets an incentive for participating in the network. Creators, maintainers, and so on and so forth. Yeah, so where are we in terms of like actualizing this vision? I mean, the vision is great. You as a creator or contributor is going to get your fair share out of the work that you do, but which blockchains out there are actually materializing that vision? So if you look at the top 100 projects, let's say in the blockchain field, so everybody is following like their own approach, or so everybody has their own vision, their language of choice. Some didn't even have interoperability as a consideration. For instance, take an example of Bitcoin or Ethereum. So when they were built, like back in the day, we call them legacy blockchains, although they're just like 10 years or 13 years old, because they were built for specific applications, and then they didn't think very broadly. Okay, so for instance, like Bitcoin can't communicate with Ethereum, so there's no native capability for that. You always need intermediaries for bridging those two, and we all know what happens with bridges, right? So whenever you introduce intermediaries, they are always susceptible for attacks. So communication between like blockchains was never the focus of legacy blockchains. The other thing is poor security. So here we're not talking about Ethereum or Bitcoin. They have amazing security. It's not easy to hack Bitcoin or Ethereum. There billions of dollars are in that network. So if you really have to influence that network, you need to put a lot of capital in there. But anyway, so apart from that, like if you go to blockchains that are way below, it's easy. Governments, if they really want to take those blockchains down, or not just governments, it can be any sort of entities out there, financial institutions, they have the ability to take down the blockchains. And this particular thing, data structure, it won't change, but the new block that gets added, they have the ability to have their influence on that block. Although they can't change like the history, from now on, they're able to exert influence by taking over those blockchain networks. So the other thing is poor governance. So for instance, Bitcoin doesn't even have governance. Ethereum has a bit of governance, but it is off chain. People discuss like what needs to go on chain. So it's a problem. Again, like there could be some people who are agreeing to something and a lot of people like disagreeing to something. So governance is a problem for many blockchains out there. Scaling problem, for instance, like Ethereum. So it's fundamentally not built to like scale really well. You might have noticed if you use Ethereum blockchain, the gas fee is very unpredictable. So you as a developer, if you want to deploy an application, the users can access it on one day for, let's say, $1, and the other day they need to pay $100. That's not how applications should be deployed or working, right? So you need a proper scaling model, a proper predictable model when you're deploying your Web3 applications. Customizability, again, if you choose like EVM, and then smart contracts, like you're restricted to what that EVM machine can sort of provide you, right? So you can't take you can't think like very independently, bring a lot of functionality into it. You're restricted by what you can do by the platform. And the final one is like upgrades. So to upgrade a blockchain is like a huge task. You might have heard of the Ethereum merge. So Ethereum merge required like coordination of so many entities. And can we make a better pipeline for upgrading blockchains? So upgrading blockchains like Ethereum requires a lot of coordination. You need to talk to all the node, the people who are running the nodes to upgrade the software to the latest one. If they fail to do so, they'll start like creating a fork. They'll be producing blocks on a separate chain, and the ones who upgrade it produce the blocks on a separate chain, and it'll be a mess. So how do we solve these challenges? Like people, when they were starting, like, the vision of Web3 is so appealing. Many people started from many directions. They all wanted to tackle specific problems, but they failed to see the broader picture and take all these problems into account when they're designing their system from ground up. So that's what like Polkadot did. So Polkadot never thought of itself as the only solution for Web3 out there. We believe that one size fits all is not true. Like, everybody has their own like needs. Every use case requires its own resources. Like, if you just want to run like a ledger with accounts and the transactions like Bitcoin, it might not need so many resources. But if you're trying to implement like social media, or if you're trying to implement use cases for gaming or metaverse or NFTs or anything like that is advanced, you need like different kind of requirements from the network. So Web3 definitely depends on openness. Like, that's how you verify that the code is authentic. You can believe in it. You're able to interoperate with it. And yeah, interoperability. It's like you as a developer, you need not worry about the whole broader picture of like Web3. You can just focus on your application. You can start building it, and you should be assured that everything else down there is going to work as expected. So yeah, so Web3 definitely depends on openness and interoperability to work. So this is our take on it. And that's exactly what Polkadot is doing. So Polkadot, we show this image always, like, when we're introducing Polkadot. So if you take a look at these blocks right there, so this is the Polkadot blockchain. So it's called a relay chain because it's connecting all these, these pink blocks that you see. Those are parallel blockchains that are running, so these are blockchains as well that are running in parallel to the Polkadot relay chain. And the beauty of this is every single parachain, because parallel blockchain is called like parachain in our ecosystem. So every blockchain can create its own rules. So some of these parachains, they may not even have like a token, they can be token free. Some of the parachains, they can focus only on DeFi. Some of the parachains can focus on social media or identity solutions or so on and so forth. And because every individual blockchain like runs its own logic, it's very different from, if you heard of like sharding. So in Ethereum, sharding like architecture, which is not deployed yet, what they say is like all of these individual shards are going to run the same program, same logic as Ethereum. Whereas Polkadot, we already have sharding implemented in the production, production system out there. Every individual shard of Polkadot is this parallel blockchain. So they are heterogeneous. So they are all unique, and they work on their own. And yeah, that's why I say Polkadot is the first production-ready heterogeneous multi-chain sharded, protocol that actually like connects all these blockchains together, provides them with like security that they need. So nobody should be able to attack these individual blockchains. If they have to attack a single blockchain on Polkadot, parachain on Polkadot, they need to attack the entire Polkadot blockchain. So every single chain is protected by Polkadot security, and also the interoperability that it provides. Like if this blockchain wants to talk to another blockchain on Polkadot, that communication should be secured by the entire Polkadot security. So here is where I'll show things in action. So rather than just talking over a slide, I'll show the Polkadot blockchain in action. So let me share the Oh. Okay, so everybody needs some tooling to interact with the blockchain, right? So this is one of the tools that is available to interact with Polkadot blockchain, Polkadot.js. So this is one of the extensive libraries out there to interact with the chains within like Polkadot ecosystem. So you can see, so a list of like all the parachains. All of these are like blockchains that are running on top of Polkadot. Not just these, like you also have, we have Kusama, which is like a canary network. It has like parachains of its own. We have like test networks. We have other live networks, which are not part of the ecosystem. They're like running on their own. That's the beauty of like Polkadot. The substrate framework, which lets you build blockchains. You can make them part of like the Polkadot ecosystem, or you can run them independently as well. So we'll talk more about that in the next session. But let me go to the Polkadot blockchain, right? So let's interact with it. And all of the endpoints you see here are some node operators who are generous in letting you like interact with it. So if you don't want to like trust any of these people, you can actually run your own local node. So all you have to do is go to Polkadot repo. So Polkadot GitHub. So check for like releases. So you have, so right now Parity Tech is the one who's creating, releases for Polkadot. We're also like diversifying it. Like we believe in client diversity. So this client is built using Rust. So we're also funding people building it with like Go, C++, and other languages. But yeah, all you have to do is you can download like the Polkadot node, run it, and then you're able to change it to local node, and then do the RPC request through your local node. You don't have to actually use any of the third-party people here. But for now, I'm not running the node today, but on Friday, I'll actually run a node on my machine and then interact with it and show you a live demo. So let me switch to that. And yeah. So you can see that the network has some events going on. So this gives you a sneak peek into what's happening in the network. Okay, so somebody with this account has transferred so-and-so amount of dots to that particular account. And yeah, so somebody is doing like staking. And soon you'll also see some things to do with like parachains or other events on chain. So right now what's happening here is you have validators. These are like nodes who are creating like blocks, adding it to the chain like every 6 seconds. So every 6 seconds, like a new block is being produced. This block is containing all these events, which are sort of set in stone, right? So when do you exactly know that it is set in stone in Polkadot? So Polkadot has these two things right there. So one thing is it's showing like the best block and the finalized block. So the block finality in Polkadot actually takes 3 block times, which is around 20 seconds. So if you do a transaction on Polkadot, after 20 seconds, you can be assured that it is sort of finalized. If you look at like Bitcoin, you don't have that guarantee, right? So Bitcoin has probabilistic finality. So let's say I sent you some Bitcoin like now, you'll probably have to wait for 3 or 4 hours so that enough blocks get added on top of the block that has this transaction, so that you're confident that nobody can rewrite all this block history with like a new chain, right? So Polkadot is kind of advanced in that way. So we have like a hybrid consensus model where we have like forks existing, which are of the length like 3 blocks, but we have grandpa, which is like a finality algorithm that's going to like finalize the transactions. And after your transactions goes into that finalized block, you can be assured that it's final with a disclaimer. So there's also what's called like slashing. If you're aware of like how proof of stake systems like work, if somebody messes up with the transactions, there is a penalty issued to that particular validator, doing that that sort of activity that's not that's malicious to the network, and that's shown here. So if there is any slash applied on the network, you'll see it, and yeah. But anyway, so you can clearly see that the network is operational, and then we have like parachains. So I talked about all these individual blockchains that are running in parallel, right? So you can see them actually here. So statement, it's like a common good parachain on Polkadot. By common good, I mean to say there's no so the team that works on this, they don't have their own individual token. They create infrastructure, they create this parachain for the Polkadot relay chain and ecosystem. So it's for the common good. Think of like the roads that you use, the highways that you use in your states or in the country. Those are like common good infrastructure. Somebody pays for that, but everybody can use it. So statement collectives is such such blockchains, parachains on Polkadot, which are common good. And then you have blockchains like Akala, Moonbeam, Astar, and so on and so forth. All of these are built by individual teams, like, a group of developers, forming like a project, doing like very specific things. Like Akala is doing some DeFi related stuff. Moonbeam is like whatever you can do on Ethereum, you can do on Moonbeam. So Astar is doing like a hybrid. So they have EVM support as well as like WebAssembly based, like, smart contract support, which is rolled out like recently. So LitEntry is doing identity stuff. Nodal is doing Internet of Things, like, so and lots of interesting applications. So Hydra is doing some Omnipool for DeFi. BitGreen is doing a lot of carbon credits related to like greenhouse emissions, putting that on chain. So they're doing that. Water Network is doing something with commodities. Frequency is doing like social networking on Polkadot. So plenty of these blockchains. So every single parachain you see has its own block number here, right? So Frequency has 1 million blocks, whereas Zeitgeist has like 2.8 million blocks. Statement has 3.7 million blocks. So all of these are individual, sort of independent blockchains that are running on top of like Polkadot. So here you can see that they're producing a block on an average every 12 seconds. So there are improvements in the Polkadot protocol that will bring down this block production time to 6 seconds. On par with the relay chain's performance. So you can expect like 4 to 10 times improvement on parachain performance. And this is scheduled to be rolled out sometime later this year. And as you can see, every individual parachain is being assigned with a set of validators. These are the nodes that belong to the Polkadot relay chain. And every minute or so, you see that this group is sort of shuffled. So for someone to be able to attack a parachain here, they should know ahead of time the scheduling of which validators are going to be assigned to this particular parachain for this particular minute. So all of this scheduling actually happens when the staking election. So every 24 hours, like we have like staking based like elections of these validators. They get like their slots assigned then. And then within that period, you have to track down these validators who are shuffling and then sort of exert. If you want to exert influence on a particular parachain, you need to do so much of work, in sort of doing DDoS attacks or sort of acquiring these validators somehow. And if they're running in a decentralized way, it's very, very tedious or very tough, right? So you see the issue with attacking a chain that is running on Polkadot. So that's why we say, like, if you really want to exert influence on Polkadot network, you need to have at least 1/3 of the validator set on Polkadot to be able to exert influence, and that would cost you a lot of resources and money. Anyway, so you would have noticed like the validator group is just shuffled from 21 to 22. So this keeps happening throughout the day, and the next day when the new validators get elected, it's going to happen the same. So you can see, like, when I'm saying Polkadot secures all the individual blockchains with its full might, this is what is happening in the background. All right, so let's go back and yeah. So I hope this slide makes more sense now. So every individual blockchain, parachain that is running in parallel to the relay chain is heterogeneous. It has its own state transition logic, its own use case, its own parameters. And yeah, so all of that is being secured through the relay chain validators. And all of these blockchains are also talking to each other. So I forgot to show you this beautiful dashboard. So let me show. Let's go to Polkadot. And then let's go to XCM, which is like cross-chain communication. Yeah. So this is how. So I showed you like Astar, Hydra, or Akala right here. So all of those are talking to each other. So they've all established channels on the relay chain, and they're talking to each other. So if you take a look at Yeah. So in total, like 200,000, messages have been transmitted across like all these parachains. So between like individual parachains, you have like transactions happening, and all of these transactions, they're being secured by Polkadot. And so if you have like a blockchain running like a dApp, and it wants to access like resources on another parachain running elsewhere in Polkadot, this XCM channels are going to assist you to import them as if they are your own tokens, right? So it's that we're talking about that level of interoperability where you don't have to worry about like the bridges getting hacked, or people losing their multi-sig keys, or all these issues you keep hearing elsewhere. So in Polkadot, it's not there. So it's all done through the relay chain, and these transactions, interchain transactions, are set in stone on Polkadot blockchain. All right, so let's do. Yep, so Polkadot secures those blockchains, and then they can talk to each other. So Polkadot is a set of blockchains that work together and talk to each other in simple words. So if you were to explain it to someone who's not very technical, this is what we would say. So Polkadot, it's not just a single chain, it's a collection of chains that are running on top of the relay chain, and they're all talking to each other, and then they're all being secured by the relay chain. Now, for every single problem that I mentioned earlier, Polkadot has like a solution from ground up. So we came up with this unique XCM architecture to sort of connect all these networks together. We can handle heavy traffic. So think of like the relay chain, and then all these parallel blockchains that are running on top of it. Look at 100 blockchains like running on top of like relay chain. Think of how much scaling that can actually bring towards what you can possibly do. So industry leading security. So we use nominated proof of staking. We do one of the most sophisticated staking algorithms. We run that on chain. I mean, at least we run the solution off chain, and then we import that solution on chain, and then we use it. And yeah, so we have industry leading security for a brand new blockchain. If it becomes like a parachain on Polkadot, from day one, from block one, it enjoys the Polkadot security, which is currently around like $7 billion. So we have, yeah. So as you'll see, you saw all those individual parachains doing like their own thing, right? So individual use cases. So Substrate blockchain building framework enables like custom made applications to be built. And Polkadot also has like amazing on-chain governance. It's possibly, again, like one of the most sophisticated governance mechanisms out there. I can actually show things in live for you. Let's go to, yeah. So actually, Polkadot will soon have what's called like OpenGov, which is a unique governance model, very decentralized. What you can notice here is that there are 13 referenda that are being voted on by the community. You have this level of community engagement on the blockchain. So Polkadot doesn't have OpenGov yet. What we have is like the previous governance model, and this thing only allows for a single referenda to go through. So let's see. Yeah. So a single referenda through the public queue, and then there could be referenda that are sent through by the council or like the technical committee that sort of fast forwards things like you. But there is not a scope for a lot of governance activity on Polkadot. So every single thing takes 28 days, and then 28 days for enactment. But soon this will change. Like you're going to have different tracks. Low priority tracks, high priority tracks, treasury spending tracks, and so on and so forth. So you'll see plenty of like changes in terms of like governance, and Polkadot is leading the way through like governance in the blockchain space. And then finally, this is my favorite feature of Polkadot. So there's no need to do hard forks or anything on the network, you can actually upgrade the chain like you upgrade like an app on smartphone. So you basically deploy an update on the blockchain, and every single node that is participating in the blockchain network gets that update through the network. So they don't have to download a new software or node client from GitHub repository and then run it. So they actually get the updates from the network itself. So for the team that has built like Polkadot, so if you're familiar with Ethereum, so Gavin Wood was like the CTO. He wrote the yellow paper for Ethereum. He's one of the creators of Solidity language. Worked very well on like EVM, and has also created like Ethereum clients through like Parity, which is the company that's building like Polkadot as well. So Gavin Wood established Web3 Foundation, which is where I work at, and started the project like Polkadot along with the other two. So Robert Habermeyer, like he did a lot of core protocol development. Like he has been instrumental in creating like the consensus engine, the grandpa finality that I talked about like earlier. And yeah, so I already showed the network in action for you. We have like plenty of nodes. So if you're interested, I can actually show that to you like live as well. So telemetry.polkadot.io. So it's going to show you all the nodes that are running like, on Polkadot, on Kusama, like live. So you can see here that we have like nodes that are running almost, on every continent. Each node listens to the network. Once the block is broadcasted by the validator, they all pick it up, they add it to the blockchain that they are, running on their local machine, and then, take part in the whole network. So when I'm saying Polkadot network, it's not running on a server or so. It's all of these nodes put together, right? So you're interacting with this decentralized set of nodes that are out there. Yeah, we talked about this. Like Bitcoin is good at what it does. It keeps track of like account balances. Very good. If you transfer something to someone, it is set in stone. Like nobody should be able to modify that or say that you're lying that you didn't transfer. So Bitcoin does a great job of keeping track of that ledger. And Ethereum takes it a little further. So it's almost like a computer, right? So Ethereum blockchain is like a computer, decentralized computer on which you can deploy programs which are executed using Ether as the gas. And yeah, so the way they're executed is in a decentralized manner. So it doesn't matter if like government of the US, if it wants to shut down a certain code from being executed on Ethereum, they'll have to exert influence on the entire Ethereum network. Right, so that is what we're talking about. We're eliminating these central authorities to have like full grip on what can be executed and what can't be executed, and that's the whole vision of Web3. So Ethereum took it a little further. It created like this generic EVM that is capable of executing anything a normal computer can execute. But if you plan to like stream like a movie using like Ethereum, then probably that's not the use case, right? So it will cost you a lot, to use Ethereum blockchain for applications like that. Yeah, so parachains are custom built on Polkadot for specific use cases. So an individual blockchain parachain on Polkadot can do anything Ethereum can do, Bitcoin can do, or name any layer 1 blockchain out there. Its functionality, it can be implemented on Polkadot parachains. So if you're deploying like a parachain on Polkadot, think of like all the L1 chains that are out there. So you can replicate a copy of that here with your own rules, with your own like tokenomics, or so on and so forth. Yeah, so I mentioned about these problems as well. So Ethereum has this problem of congestion and high fee. Also, when starting like Ethereum blockchain, they really didn't think through about how the state might grow. So now Ethereum nodes have to download a huge history of like blockchain, and so it's all adding to the cost of operating like the whole network. So all of these problems have been identified over the years, and then the latest blockchain protocols out there are taking all of those lessons learned, and they're thinking of a design which wouldn't affect or significantly increase the cost of like running the network down the line. So we talked about this, like we have relay chain, which is layer 0, and then we have layer 1 blockchains, which are being secured by the relay chain validators. I showed that to you. There is also, so right now, if somebody wants to deploy like a blockchain on Polkadot as a parachain, so they have to auction for these slots. Like they have to win an auction to be able to get this bandwidth with like Polkadot relay chain. So if you don't want to do that, so this requires that this parachain produce a block like every 12 seconds. Now let's say you're doing like an application on a blockchain, or you're creating a blockchain that needs to produce a block every 24 hours. Think of all the land sales that happen in your state. Okay, so you need not package blocks like every 12 seconds. Land sales aren't that frequent. So you can put all those transactions into a single block and send it to the Polkadot relay chain for like finality. You will still maintain that blockchain, but you're actually using Polkadot's finality to give the guarantee for those blocks or the data in that blocks. So what you could do is you can subscribe to this parathread model, so there are lots of ghost chains out there. When you say ghost chain, the chain keeps running, it keeps producing blocks, but there are no events that are being captured within those blocks. So why waste resources, right? So all you need is transactions that have to be solid, that have to be protected by the security of the blockchain. So you only send them when you have to. And Polkadot is actually giving the chance with the parathread concept. So parathreads are like on-demand, blockchains. You have to auction for every individual block. So right now you're in a pool, you say, okay, I pay so much of DOT to have my block included, and that gets included. So all of these interesting architectural ideas are being actually implemented and then being made available to the community through Polkadot. So this feature, it will go live sometime the end of the year. Yeah, so I think I'll in the interest of time, I'll sort of go over these things like briefly. I showed this to you live. Polkadot shuffles and assigns set of validators, right? So what, as a parachain, what you have to do is you have these parachains also have their own nodes. So they are different from like relay chain nodes. So for instance, let me go to the telemetry. So these are Polkadot nodes. But if I go to Moonbeam, so Moonbeam has these nodes. So these are collator nodes. So these are the ones that are collecting transactions happening on that parachain. So they package the block and then they send it to the relay chain validators. So those are collators. So they open connection with the validators. They send all the transactions that are happening along with the state transition logic. It's almost like Polkadot is like the federal government, and then the state governments, they are not enforcing the law on their own. So they're capturing all the events that have happened in the state and then packaging it into a block, sending it to the federal government. The federal government looks at all the events that have happened, and it looks at the constitution and the laws, and then it sort of checks, which one is like a valid event and which is invalid, tells the state that, okay, so everything you sent to me is in line with the constitution or laws. So you can go to the next day, you can
So Deepak, can you also hear the echo?
Yes, sir, right now we are kind of stuck.
Yeah, so Radha, we are seeing echo from your side.
Can we try to
We
end
can't
the
hear you.
screen share?
Hello, Radha, can you hear me? No, so I think it is still there is an echo. I think you can try to sign out and sign back immediately if that is possible.
We are being invaded by extraterrestrial.
Yeah, no, I think Radha could hear me, so he'll be back, guys. Apologies for some technical glitch. Radha should be back in a minute.
Yeah, so guys, don't worry, that was not alien invasion. It was just some glitch.
Yeah,
Everything is
Gayatri,
fine.
I think it should be okay. Radha should be back in momentarily. No, I think still we see the echo. Radha, can you hear me?
Yeah, can you hear me now?
Yeah, much better. Yeah, thank you.
Yeah, no,
Okay, so let's.
Yeah.
Yeah, I think it must be something to do with the camera. Anyway, so I think in the interest of time, so I'll open up the floor for questions. I'm glad we have one more session on Friday to go, a bit more into the technical depth of the things that I discussed. But yeah, so I'm open for questions right now.
Yeah, Deepak. So if you can have the team question, guys, please put your questions in the chat, and Deepak Singh will take it and help it managed.
so we have Mario Francis George raising a hand. Mario, I've given you permission to unmute. If you want, you can speak.
Yeah. Mario, can you speak? And if there is an issue in unmuting and muting, then guys, you can also put your questions in the chat box, and IBC team will take a look at that, and they will take it over to Radha. Deepak, if you can have somebody.
We'll move on to the next next question. Yeah, I think there's some issue from his end. So we have one doubt from Dinesh Chaudhary, who's asking that every block can't have connectivity with other block, then how they are communicating with each other?
What do you mean? Every block or every node?
I think he must be meaning nodes.
Yeah,
Radha,
the nodes, yeah.
Yeah, that's the beauty of the decentralized networks, right? So basically so the whole consensus model that you have to, so the whole concept of consensus is that everybody agrees that this is the canonical chain. So this is the finalized block. And then they build on top of that particular block. So so I showed you in telemetry, like every single node establishes multiple connections with the other nodes on the network. So the idea is that at some point of time, in some time window, everybody gets that block information. So every node has a inbuilt functionality to ask for the next block from the peers. So it gets it from the peers, it attaches there, and then it keeps building those blocks. And so it has the idea that, so within those blocks, it has the information about the votes as well. So grandpa consensus is going to happen through like a voting mechanism. So you can actually, as a node, you can run those extrinsics on your own and say, okay, so this particular block has been finalized by these particular validators who are assigned in this era. So you're not believing anybody there. You're actually creating your own blockchain out of like the information that you get.
And Radha, just to a follow-up question on this from my side. So all these nodes will have their own mempools and everything, just like the way it happens, or how do you have the transaction broadcast and the P2P gossip mechanism? That is something similar, or we have different implementation here?
Yeah, so in Polkadot, like there are privileged nodes, right? Like the validators are elected through staking, the nominated proof of staking. So right now there are 300 active validators around, like on Polkadot network. So these are the ones that are active. Everybody is sort of establishing connection with the other one. So they're all, so even when you see like validator groupings, which had like 5 validators per parachain, so they're establishing a connection with the parachain collator. So whatever block the parachain is sending, these 5 validators are going to receive it. They're going to validate it. They're going to vote on it, and then sort of like put their certificate in the relay chain. But yeah, coming back to your question, the implementation for these privileged nodes, it's all the same. So they all have like mempools. Eventually the idea is that it gets, if a block producer is not including something that another validator has already listened to, when it's their turn, they sort of include that in the block that they create. So
understood. Okay. Yeah.
Yeah, thanks, Radha. So I'll ask Mario to speak if you are able to, or can you just type your question, whichever you are comfortable with. Please go ahead, Mario.
Yeah, Mario, please go ahead.
Hello, sir. Can you hear me?
Yes, we can hear you. Go ahead.
Hello, Praveen, sir. Hello, Radhakrishnan, sir.
Hi.
It's a great honor talking to you actually, because my sponsor is Polkadot. So I had been working on a project of mine like for around 7 years, and when I attended Alt Hack Chennai, this concept of blockchain was very inspiring, and it got even more interesting when I started getting more into the concept of Polkadot. So you talked about the concept of relay chain, sir. In relay chain, you can connect a set of blockchains and they will communicate with each other. That's where I got my idea. I wanted to create a private relay chain where 4 certain people will work together. Like those 4 people will have 4 certain tasks of their own, and these 4 people are connected to each other to buy things from each other. So in that way, let's say there are 4 chains, 1, 2, 3, 4. 1 has to buy from 3, 3 has to buy from 2, 2 has to buy from 4. So through a central node where I will be in a decentralized manner controlling them, I will also be getting my share of the money. They'll also will be getting their share of the money. And in that way, in a decentralized way, they'll be given equal pay. The advantage over here is the people who are going to be working on those 4 particular sectors are people who are treated as the most unemployed people and are not given opportunities, especially in education as well as in job opportunities. I'm not going very in depth on the topic. That's
So what you're doing is like an idea pitch right now. So I'm
yes, sir.
happy to like definitely discuss on that like later on. So for that, you wouldn't need like a relay chain as far as like I understand. So I saw another question in the chat, which is asking what is the exact use case of interoperability. So think of like Bitcoin, right? So Bitcoin is like a blockchain. Everybody trusts like Bitcoin. How do you bring the Bitcoin level security for using that Bitcoin token on Ethereum, right? So that's the interoperability we're talking about. So if we were to get like Bitcoin on like Ethereum network, it will always be some sort of derivative of Bitcoin, right? So because Bitcoin never leaves Bitcoin network. So this interoperability, why do people need it? Because, sometimes a simple analogy is the country that you're living in, it's not producing everything that you need. You want to get something from someone else who is doing like a better job of doing a certain service or a certain commodity or product. So interoperability is like a proper trade route, a trade route that is protected so that you can exchange your goods without having any sort of fear of someone will plunder this exchange, right? So a lot of hacks that you see on bridges. I mean, the whole use case of bridges in blockchain ecosystem is interoperability. You won't bring something that's happening elsewhere in a different ecosystem into yours, and then you want to be sure that you're going to be able to do that without any attackers affecting like the whole transaction. Yep.
Yes, sir. I get the point, sir. I mean, of course, I'll also be meeting you in later sessions. So that time I'll come out
so
with
we
better
can
more.
discuss that. I'll talk to you like exactly what are the use cases of relay chain, and based on your idea, like we can see like the best model through which like you can implement using the building framework.
Thank you, sir.
Yeah, thank you, Mario. So rather one question that I am reading here is basically they are talking about the algorithm by which these validators are selected. So the question that Dinesh is asking that is there some kind of predictability there, or I mean we can be sure about it.
So when the validators are assigned to like parachains, so we use like a verifiable random function on chain. So the predictability kicks in. I mean, at the beginning of every era, every validator knows which time slots they are sort of validating. So yeah, so 24 hours like window you have, to actually create like an attack if you wanted to. And we are having the next generation, validator selection algorithm. It's called sassafras. So here we're applying some zero knowledge. So what it does is only the validator knows like which slot they're going to be, validating. The others, they have no clue. So it's going to add like an extra layer of like abstraction right now. Right now, like everybody knows, okay, this validator is going to be assigned to this parachain and so on and so forth. But yeah, so we're improving on that. And the predictability in terms of who will come into the validator set. So that's based on the nominated proof of staking algorithm. So you can actually read through like the wiki page, which I'm going to share. It depends on the stake that we have. Like, if a validator is having a lot of nominations, so it's very likely that they'll make it to the active set.
Understood. Okay. So one question again from my side, and in the interest of everybody, that now ZK is being used. Of course, there are several usages, but then two things which are important is basically the scale and scale and security, right? So you see several side chains and L2s, they are utilizing this, such as ZK rollups, and even layer 1 Ethereum also is trying to do something in ZK to kind of scale its operation. How is Polkadot thinking of leveraging ZK? It's already much better than the rest of the blockchains, but then do you guys have more plans to leverage ZK for apart from the use case that you talked about?
Yeah, so again, like ZK, Polkadot is the relay chain, right? So we are creating like a suite for parachains to use like ZK in the applications that are they are building. But on Polkadot itself, like you benefit from ZK through, implementing it for like consensus, like in terms of like validators and so on and so forth. But apart from that, you don't need much of ZK on Polkadot. So if you think of it, right now Polkadot supports balance transfers. You can transfer dot from one account to the other. You can participate in governance. You can participate in, I don't know, what else you could do on Polkadot chain. All of those functionalities will soon be moved into common good parachains. So Polkadot relay chain will be this sort of internet layer, which only focuses on, validating blocks, staking, balance transfers. Everything will move to its own parachain. When it moves there, it opens up a lot of possibility. Like that parachain which is hosting like these accounts, it could use ZK or some sort of privacy preserving solution for transferring like dot tokens. So it could be done on that, or there are already like parachains like Manta network. They're like spearheading like the ZK proof implementations on Polkadot. In fact, they're being invited to every other like major ZK conference out there. So what they want to do is like create a payment solution that is sort of anonymous on Polkadot. So yeah, it's up to even LF0, which is based on Substrate. They're not part of like Polkadot ecosystem. They're doing something like privacy and ZK stuff as well. And Substrate gives you that suite to actually create, because ZK proofs, they're very expensive. So you want your code to be like very, very efficient. So if you are able to write it in Rust and deploy it to like WASM rather than EVM, you're going to benefit a lot from the performance improvements there.
Understood. Makes sense. Yeah, makes sense. Guys, anybody having any other question? I am seeing one question. Can we create private relay chain? I don't think so. I mean,
yes, you can. So
you can. Okay.
But how would you say that your private relay chain is secure? So right now, Polkadot has $7 billion behind it, staking on that. So if you create a private relay chain, if you're able to attract that level of capital and issue a token, then you can say your private relay chain is secure. But here the security is coming from the nominators who are staking their tokens on the network, right? So there's a punishment if the validator misbehaves. So on your private relay chain, if at all you create one, what's the incentive scheme there? Why would people like run validators? And what stops them from like misbehaving? So if you're able to answer those two questions, you can very well like run your private relay chain.
But rather, so my question would be that in the Polkadot ecosystem that we're talking about, where we have got relay chains, we have got parachains, can there be two relay chains? Like, do you have a solar system in which you have two suns? Maybe let me ask like that.
Very good question. So we have Kusama, which is like a relay chain as well. Kusama is like a copy of Polkadot running its own parachains. So we have like a bridge, Kusama to Polkadot bridge that is planned to be released sometime this year. So what we plan to do is, so again, this sort of communication between two different chains, you always have to look at it with a grain of salt. Like so what happens is the communication is as strong as the weakest chain. So if Kusama can be attacked, everything that is imported from Kusama into Polkadot and its derivatives, they are going to be attacked as well as a consequence. So you want to build bridges between ecosystems that are as strong as you. So right now, that's why Polkadot is focusing on a bridge to Ethereum, so that, so if some sort of transaction between these two has to be attacked, they're dealing with like two different like mega, chains right there. So Cosmos suffers from this issue though.
I agree.
In Cosmos, like you can spin up your own blockchain, and if something happens on yours, and there's like a bigger chain that is trusting you to do something on their chain, they get like affected. So even though Cosmos gives you like seamless interoperability, it comes with this cost that, every blockchain there is like a sitting duck. If people just want to like take over a blockchain, it doesn't cost them so much.
Understood. I think we have one more question. Just let me take a look at that. Can we restrict the communication between the blockchain in Polkadot? Gayatri is asking that question.
Yes. So being like a parachain, like you are the in charge of how you establish channels with the other chains. You can also stop some chains from communicating with you. You can create like a blacklist for the XCM messages, so they never get delivered to your chain. So as a parachain, you're kind of sovereign. Like, it's only the finality of your blocks that you're renting it out to Polkadot validators, but the whole blockchain functionality for your parachain, it's in your hands. So you can decentralize that, give away what we call like pseudo. So pseudo is like the admin privileges on the blockchain, right? To be able to do whatever you want.
Yeah.
You can give it away to the community through governance, or you as a developer can keep it. So Polkadot doesn't necessarily judge you or impose restrictions on how you handle your blockchain. But yeah, so if your question is, can you somehow block parachains from talking to Polkadot, then that's not in your hands. So Polkadot is almost like internet for the blockchains. So if somebody has to create like a filter on Polkadot network, then you have to do it through governance. So you'll have to create a governance proposal, which has to be voted by the broader Polkadot community. And then that gets passed and that gets enacted in the network protocol to actually blacklist a certain blockchain or like parachain. But by the protocol itself, it doesn't. So it's after all like Web3, everything is open to communicate with anything else. Yeah.
Understood. Okay. So I guess we have, let me just check. Yeah, so Gayatri is asking, can we explain collators first? I think Radha has already covered that, Gayatri, sometime back, where collators are the people who are collecting transactions, right?
On the parachain.
On the parachain side.
So you just need like technically one collator, one node that is running on your machine if you're running a parachain, or you can have like 5 nodes, or you can decentralize it and give incentives for people running collators. And that logic is up to you. How you choose a collator. You can use round robin method, or you can implement staking on your parachain. The one with highest staking is going to get like more blocks, being sent to the relay chain. So the logic is entirely up to like the parachain implementer.
Absolutely. And I think like Radha very beautifully explained that as a parachain, you have got all the decision-making power as to how do you come up with your decisions, your rules within your ecosystem. How do you really want to secure it? I mean, Polkadot doesn't really interfere in that. But the moment all these transactions are done, then Polkadot will ensure that there is an extra layer of security. Radha, correct me if I'm wrong, extra layer of security. Right.
So that blockchain slide that I showed in the first slide today, that is what Polkadot is providing. It's providing the secure block space for your blockchain. So you can add blocks to your blockchain, cryptographically, and be ensured that all of these are being authentically like secured and validated by the Polkadot validators.
Yeah, so I know we are off time, so just I know there is no other question. I would have one more question for you, Radha. Sorry for that. My question is that how do you handle the storage? So, for example, how do you ensure the data availability when it comes to the Polkadot ecosystem? I mean, there has been a lot of discussions around the data availability, even if we talk about Ethereum, Polygon, and all those, right?
Yes. So certainly, like we're talking about hundreds of these blockchains, like creating like their own like blockchains. So the responsibility of preserving those blockchains is on the parachain teams. So it's not on like Polkadot. So Polkadot like gets the parachain block, it does the validation, and then keeps it for 24 hours. This is when someone wants to challenge, if a validator is misbehaving, then we have 24 hours window to sort of challenge that. But every parachain, is like a blockchain, and it's the parachain that has to take care of like preserving like its own blockchain. And by giving it away to, creating these 100 different shards, we're able to like localize that problem. Like, not a single entity is, but Polkadot itself, there are plenty of so like I said, the state growth of Polkadot is much more constrained than like Ethereum. So we have like future in mind. We have like the services right now, like the common good infrastructure funded by the treasury, which is sort of preserving like the entire Polkadot blockchain. Not just that, if you subscribe to it, there are services that will actually preserve the entire like parachain blockchains as well. But yeah, all of this is like interesting design problem. Like, how do you create incentives to do something? How do you get the resources and money to do some things? But yeah, so I really have to go right now. It was pleasure like talking to all of you. Great questions.
Yeah.
I think for Friday, if you're able to like review the CryptoKitties tutorial that I've shared with you, we'll have like much more fun discussion, like developing stuff. But I hope today's session gave you a good idea of like what Polkadot is. And I'll have to like sign off very soon.
Yeah, well, thank you so much. Thank you so much, Radha, for giving your time today. We look forward to meeting you on Friday again.
All right. Thank you very much.
Thanks, Radha.
Yeah.
See you soon.
Take care. Bye-bye. Yes, Deepak, over to you.
Yes, sir. Over to you. Back to you, I would say.
Back to me. Okay. So I guess I'm sure you must have a very a thrilling session today, and especially when you hear from someone who is in the middle of all these things. We have been talking about Polkadot since our Chennai Alt Hack, and even before. We have spent a lot of time on this, and I think it is very important for us to give you access to some of these experts from the industry, and especially from such a, I would say, path-breaking solution. I don't know how many of you do realize this, because blockchains really have several issues, and Polkadot has been trying to solve many of the very, very core fundamental issues in this space, such as interoperability, the security, the scalability, because all these are the fundamental problems right now. How will this space evolve in future? Meaning that will this be a world which is dominated by Ethereum? Will this be a world which is dominated by, in fact, if you have several of the parachains coming in Polkadot, and this itself becomes a a massive ecosystem in which all different types of businesses are existing, and this becomes a multi-functional world, right? I think that's the state we are looking at, and in the whole process, even Polkadot is maturing, bringing changes to its functionalities and technicalities, right? Deepak, I'm sure we have shared the content that Radha wants everybody to go through, especially the folks who are going to be building on Polkadot. That's going to be very, very vital, and it is always good for everybody else. Like I have said in the past also, that these different blockchains have foundational concepts being the same. The foundation of the concept does not change. What really changes is the implementation and some variation in the way you look at problem, right? The way Ethereum looks at problem, the way Polkadot looks at a problem, the way Solana looks at a problem, the way Polygon looks at a problem, they have a different way to look at them, and they have got their own way of solving those problems. So it is very, very, especially in the early days, you should not restrain yourself that I would only know this, because all these concepts are very similar, very same. So it is always good, and I would request all of you to continue having as much knowledge acquisition by attending all the sessions we are doing it for you. So our team will be keeping you informed about the next sessions. Please do make a part of join and be a part of that. Plus go through the content that our team has shared. Deepak Singh, I would request that please reshare those content that Radha was talking about, so that it is in fresh memory of the people.
Yes, sir, absolutely. So, guys, so Radha has shared another link today, the wiki link of the Polkadot network document. So, please just go and check that out as well. And I've also shared a link of the CryptoKitties that Radha was speaking about which we'll be addressing on 28th April, which is on Friday. So, the link of that document is also there in the chat box. Just go and check it out and save the document for resources. And at the same time, tomorrow we have a session coming up on by Chengari. We'll have an expert trainer from we'll have an expert from Chingari coming in and explaining you just like Radha did today about their network, about their blockchain. And what's the best part about these experts is that when they come, they the knowledge that they share with us is backed by so much experiences which comes from their own blockchain, right? So a true real world challenges or the solutions that you would want to address or learn from would be coming from these people. So I request all of you to just be there. Even though you have not been allotted the Chingari track, doesn't matter, you should definitely be there to learn from these people. And they also have some list of resources that you should definitely check out. And let me just share that as well with you in the chat box. Yeah, so these are some links that you should definitely refer to have some background before the session which begins tomorrow at 7 p.m. same time. The link will also be the same. So make sure you use these resources to refer. We'll also be sharing the same in Discord. So make sure that I'm sure most of you are already on Discord. If not, then please join and just make sure that you are connected with everything that we are doing here. Yeah, Praveen sir, anything else you would like to add before we conclude the day today?
No, I think after such a scintillating session from Radha, I don't have to say anything. Thank you guys for joining today, and I am pretty confident that you all are turning into a fantastic Web3 developer. And please continue your journey. Don't stop in between. And I am also here to help you with several things in in my capacity as to what I can help you functionally and technically. Okay, that's pretty much Deepak from my side.
Absolutely, Praveen sir. Thank you so much for joining in with us today, and obviously giving some guidance to us along with Mr. Radhakrishna. And guys, make sure you connect with our speakers and the experts here. It's always good to stay connected, and you can just ping them if there's something interesting you have in mind and share ideas. Not, I mean, don't pester them. Like every morning, evening, afternoon, you want to just hammer them with messages. But yeah, just remember that people are always in Web3. People are always eager to collaborate. They always like interesting ideas, especially when you back it with a lot of knowledge and skill that you will be able to execute. So what we are doing here is giving you that skill to pack your idea with the knowledge and the implementation at the same time by building things. So yeah, whenever you get time, just go and practice whatever you learn, because practice is what will actually help you in the next coming days when we are building projects in your own sponsor networks. Once again, everyone, thank you for joining in. That will be all for today. Praveen sir, once again, thank you for joining in. Deepak Chaudhary,
Yeah.
Deepak Gudem, thank you for organizing the session and also helping us with the question and answers. It was a great session today. We'll be coming back with more, even more insightful session tomorrow with Chingari, and day after tomorrow, once again, we'll be back with Mr. Radhakrishna. So guys, all the links have been shared on chat. Make sure you access them, make sure you refer to them, share it with your friends. It'll be exciting conversation to just talk about some brilliant stuff that's out there. So do join us tomorrow and day after tomorrow as well. Thank you everyone for joining in once again.
Yeah.
Have a great night. See you all soon.
Yeah, and thank you, Deepak. Thank you so much.
Thank you, sir.